Welcome to another edition of Coinomi Connect AMA. In this session, our host Duane sits down with our new partner Cellframe for a deep dive into crypto and an introduction to their team. This conversation was recorded live on X Spaces in September 17th, 2025. Please note, the views and opinions expressed in this AMA do not necessarily represent those of Coinomi Wallet and should not be considered financial advice. Always do your own research on the projects discussed. If you enjoy the video, don't forget to like and subscribe to support the channel. Now, let's get started. Enjoy.
Hey, yeah.
Okay. Yeah, it's just a minor hiccup, but I guess we can officially get started right now if you're ready, or do you need anything or anyone else from the team to join in before we officially begin?
No, just me today.
Okay, so hello and good day to everyone that is currently tuning in here at Coinomi Connect, and today we have a very special episode, this time with Cellframe. And we have yet to know what Cellframe is going to be all about, and as I mentioned, the one that we got is Gleb from Cellframe. How are you doing? And welcome to these spaces or Coinomi Connect.
Yes, hello. Yes, this is Gleb from the Cellframe team. Very nice to be here with Coinomi. We recently partnered with you guys to do some fun events and to host our Cell token, and it's great to be talking to you guys.
Yeah, and you know what? I have to say this up front. It is a really interesting project that, especially since you got one of the main things that you have in your project is quantum. You know, the most amount of times I've heard quantum is when I'm watching Marvel movies and stuff like that. A lot of quantum physics kind of things happens with that, but we're talking about quantum computing here. And I know it's still quite early to get into technical stuff, but before that, I'm just really curious about that. Can you tell us more about yourself, your team, and maybe a bit of an introduction to Cellframe itself?
Yeah, sure. Yeah, quantum is such a buzzword, and you're going to be seeing a lot of kind of fake quantum projects popping up because it's such a fun word. But we do a quantum proof blockchain. That's we can talk more into what that means in a bit. So, yeah, my name's Gleb. I come from a humanities background. I've been interested in blockchain since around 2014 and been working in it for, maybe since 2018. And the past 3 years, I've been lucky enough to join the Cellframe project, which has been amazing for me to learn a lot. Still learning about Cellframe. Oh no, my dog is making some noise over here. Excuse me. So yeah, and so I've been there, and we're it's a full service, brand new blockchain ecosystem. So it's a very ambitious project in a way, but it makes sense when you think about it in terms of, looking at what Web3 needs to be, as far as like everything in your phone should be, we think, peer to peer. Everything should be run by crypto micropayments and distributed networks. And so when you look ahead into that future of really what Web3 should be, and you think about how to make infrastructure that's going to last for that future. And really, the previous generations of blockchains haven't done that. Bitcoin was made as like a great idea that, they programmed it. It was a brilliant project. Ethereum, they came up with some new, concepts with the smart contracts, but no one took a step back and said, okay, how do we build an infrastructure that's going to last? And that's what Cellframe is trying to do. And quantum is a big part of that, because if you're looking at infrastructure, you want to build a bridge. You don't want to build a bridge across a river where you're going to have to rebuild it in 3 years, right? And one major part of Cellframe's attempt to build a truly infrastructural Web3 platform is to be quantum secure. And so what that means is, basically, quantum computers are real. They've been developed actually since the 70s, and there's certain calculations that they can do that people have known about since the 70s. Up into the 90s, they started really experimenting with it. And now we've come to a point where it's very close to actually having the hardware to run those calculations. And they have a special ability, unique ability. They're actually not that useful across the board, in all kinds of science, but they have some pretty amazing things that relate directly to blockchain and cryptography. And one of their capabilities is to solve the functions, the algorithms that are used to create the two-sided cryptography, what we call asymmetrical cryptography, used in blockchain and actually used all across the internet. Right. So we're approaching a time where Cellframe's goal to build something for the future that's really going to last is coming up to a point of the quantum apocalypse, as we call it, and all other major institutions that rely on cryptographic security have already adopted what we call post-quantum algorithms. So Google, Microsoft just released a big plan of how they're going to roll it out. The government is already requiring it in their part, their security partners. So that's why Microsoft has jumped on that. Meta has already got post-quantum in their messenger apps and stuff like that. So that's what part of what Cellframe is built into, is to be ready for that quantum future. And it's actually a very big thing, because a blockchain can't just upgrade its security the way a bank or Meta can. You actually are going to have to migrate every single token you have to a different wallet with a different, more sophisticated cryptographical signature in order to be quantum safe. So it's a huge problem for the legacy blockchains. So that's why, I think you're going to be hearing more and more about Cellframe and different projects that are quantum secure, because that's coming up, and it's going to be a huge issue for the other blockchains to migrate. Hope that wasn't too wordy for the background there, but just wanted to dive into it.
Yeah, you kind of took out 3 of my questions already. That was just that, which is great. That means more time for other questions. But when, as I mentioned earlier, when you mentioned quantum, like not just you, like in general, it seems from what I understand it's like calculations, computations way beyond of course, human comprehension and the technology that we have maybe a few years ago. But as you mentioned, now quantum computing or just quantum in general, I'm not sure if it's two different things, quantum computing or just the word quantum in general. Uh, is it
Hmm.
somehow related to AI? Because you've mentioned, Meta is also working on it, and I would say everywhere, even outside Web3, that AI is everywhere. Is it connected somehow to quantum? I'm sorry, I'm not well
Yeah.
versed with that one. Yeah.
No, I mean, hey, I've been researching this for over 3 years, and I'm still kind of a baby in the field. But I can try to tell you a little background. I mean, so quantum physics itself, it's like theoretically very crazy. Like things existing, teleportation, like
Yeah,
basically.
just in the movies and sci-fi movies. That's where I usually hear that getting applied.
No,
Yeah.
no, no. But no, literal teleportation, right? Because the Einsteinian laws of physics state that information can't travel faster than the speed of light. But in quantum mechanics, you have this thing called quantum entanglement. So different particles can have a spin that they share characteristics, and you can move them apart, and instantaneously when one changes its spin, the other does too. So there's actually been experiments with this, like they've teleported quantum states like across long distances. Anyway, so those are the experiments in quantum mechanics as such, and then those are actually applied in the quantum computers themselves. So a quantum chip has these electrons. So instead of a gate in a classical computer, 1, 0, 1, you can have multiples. Basically, it expands that to a multiple states. So, and in that case, then you apply different algorithms that can't be used in a classical computer, with silicon, and they can be used in a quantum computer in a way that, like, instead of guessing one number at a time, it can guess many and exponentially increasing. So these are sort of like very small chips right now. But the problem is, for people there are quantum computing skeptics out there who don't believe that these little chips with their quantum states, they're very fragile. They need to be cooled, and there's different people constantly innovating in that space. But what we see are already existing quantum chips being produced by certain companies en masse. And Meta is not actually one of those companies. Meta is just sees the quantum computing threat and has done that. But there are companies like IBM, which produce chips. Google has a chip. And there are also specialized quantum computing companies out there that are building their own, like in Cambridge. Anyway, so these chips, we can see they have timelines where in the next 5 years maximum, they say they'll have a strong enough quantum computer to do this encryption breaking. And that's actually one of the first big tasks that we see quantum computers able to do. It's kind of a paradoxical situation where we want them to do crazy stuff like AI, you mentioned, and scientific research, modeling genes, modeling molecules for chemistry. We want all that to happen, but the actual easiest thing to do with a basic quantum computer is to crack Bitcoin and steal all the Bitcoin. So that's the situation where we're in, is that these quantum developers are building, but what's their motivation in the end? Well, in the far future, we believe we'll be able to do great things. Like, for example, you mentioned AI. Right now, we're coming to a point where, Elon just built his gigafactory computer, right? The most giant data center ever built, right? But we're reaching a point where we can't get that much more efficient with the regular chip, the silicon chip, because of the size of the atom and things like that. They're so small. So people are hoping that quantum computers will be able to push computing further, right? Because if our brain works much more like a quantum state than a yes/no computer, right? So we're thinking, oh, maybe artificial intelligence as we envision it can actually be done in quantum. But that's further down the road. We're dealing right now with this real situation in the next 5, maybe 2 years, where you can have quantum attacks on Bitcoin, right? The big wallets. And the thing is that, just to go get back from quantum to cybersecurity real quick, I'd love to talk more about quantum also, but some of the OG wallets can actually be cracked with classical computers now, because they have some vulnerabilities. You can guess some of the numbers, and if you can guess some of them, you can already crack them with a really powerful supercomputer. So when we say that Cellframe is post-quantum, we're actually talking about just having that next generation of security that protect against any kind of supercomputer attacks on the signature.
I see. And, I guess from what I understand, it's just quantum kind of hacking, which makes it easier for hackers once they have this kind of technology to hack, especially, Bitcoin wallets and stuff, or any blockchain kind of wallets and stuff like that. So based on that alone and how fast technology moves, how long do you actually see quantum computing, quantum protection can actually cater to the the security needs that we have today, or is it continuously evolving as time goes? So let's say what you have right now is good for quantum compute, quantum. Sorry, I'm getting lost with my vocabulary, but yeah, let's say for the next 3 years it's going to be good. Do you think after 3 years it'll just continuously evolve the technology or the security of the quantum protection that you have right now, or is it going to be a totally new kind of technology?
Yeah, that's a great question. So yeah, what we have are what we have implemented in Cellframe, and what other major tech companies are doing is something called quantum resistant algorithms. And those are good. We believe, there's good mathematical reasoning to think that those will last a good long time in the quantum world, right? So, if you have the computer that can crack Bitcoin, in an hour, say, it would take maybe many years for that computer to crack what we call a quantum resistant algorithm, or even more, right? So these are algorithms that are designed to mathematically survive the quantum age as we see it, in the near future. But you're right that it does have to evolve. New algorithms are being designed, and part of Cellframe's design is to be able to change its encryption type. So that's the thing that the OG blockchains don't have. They have to migrate, and it's much more difficult. So yeah, we're implementing the latest algorithms that are available, that are approved by the NIST, which is a American but also global body that is very powerful in this field and sets standards. So we want to meet the post-quantum standards. But yes, and then we possibly, as the quantum age develops, we possibly need to upgrade those algorithms, and we can do that. And then in the kind of real quantum future, there's such a thing as quantum cryptography. So this is kind of confusing, because this isn't about being post-quantum. This is about actually using quantum technology to do cryptography. So that's kind of it's a little bit sci-fi, but it also already exists in some ways, because there are companies working on this. Excuse me. So that actually is a pretty cool thing if you want to look it up. But it's basically you send whoever you're sending your message to, you kind of like you have your particle with its information, and you beam a particle to them, and you can teleport that information back and forth using quantum physics, and that's called symmetrical cryptography. And that's like the holy grail of cryptography, because there's no way you can reverse engineer it the way you can with what we're using now. It's like a pretty amazing. So the quantum computing itself has some really cool applications in quantum money. But that's a little farther into the future. Right now, again, like I'm saying, we're dealing with preparing for the first quantum era, let's say.
We're getting close to what we see in the movies. I mean, this is a step there. So I'm glad that you guys everywhere in the tech space are developing stuff like these. And now going back to the crypto Web3 aspect of things, because from what I see, there are two things that are really important right now in blockchain technology. One is, of course, security, and the next one is speed. It's never fast enough for a lot of people in crypto space. Like even a few milliseconds can spell out differences and having a huge gain or a huge loss. So that being said, you have anti-quantum mechanics in Cellframe. So does that also mean that you have faster computing technologies, or just transactions that's happening within your chain?
Yeah, so that's a good segue. So basically, the concept of performance and speed is related to the quantum thing, because, well, first of all, they're both related to the idea of infrastructure. We want to be able to build rails that can handle any amount of scaling and any amount of speed, transaction speed needs that we might have in the Web3 future. And the thing but scaling is actually different in the post-quantum space than it is in the classical cryptography space. So some of what, for example, Ethereum is doing to scale isn't going to work with post-quantum algorithms. So some of the ZK architecture, for example, some of those. So we want to be able to scale, but we also want to do it to scale in post-quantum, and we also want to be truly decentralized. So that's a big part of Cellframe's ethic. So some of these layer 2 solutions that are kind of like off-chain, we don't really like that. So we've developed a scaling solution that's both simple and extremely powerful and high performance. We call it dual layer sharding. So it goes back to the old idea of sharding, but we also have 2 layers. So we have shards that are homogeneous. So these are the cells, what we call. So each app can have its own chain, and that way the traffic gets grouped by those types of transactions that are common to that app, say, or that project. And then we have another layer of sharding that's kind of dynamic, that as the traffic flows, new shards are created, and we can basically scale to an infinite degree using this type of architecture. So it's both simple but also extremely advanced in its ability to have basically unlimited scaling. So that is a big part of what Cellframe is built. So I'm glad that you brought that up here at the beginning. So we need scaling, we need extremely high performance. So Cellframe is written in pure C language, which is able to work with the hardware in very efficient ways. It's able to execute very quickly and without a lot of memory usage. So all these aspects are built towards extremely high performance, and that includes the sharding that I talked about, and then the challenge is to do that in a post-quantum space where the signatures are actually much more bigger file sizes. They have different characteristics, so the scaling issue is very interesting to look into. But yeah, so shorthand for it is what we call it dual layer sharding. That's the plan. So.
And I also want to get back on what you mentioned earlier. Although this is quite an evolving and futuristic concept with quantum, you've also mentioned that you guys aren't the only one that has this kind of main branding to say, which is quantum protection. So with those other projects that has the same kind of branding, um, do you have any direct competitors that offers nearly or identical to the same services that Cellframe gives off? And if you do have anyone that's like that, what do you think are something unique about Cellframe? Because it's all about competition about the space. A lot of people tend to not change if they're already using something. Why they would change to something that's like 1 or 3% different or maybe better. So yeah.
Yeah. Yeah. I mean, what I was mentioning earlier is that like people will, well, first of all, there'll be fake quantum resistant projects that are claimed to be quantum resistant but aren't.
It's easy to
There'll
say
be projects. there'll be projects. So there's those out there. There'll be projects that just use the word quantum randomly. So that also happens.
Reminds me of the projects right now saying AI this, AI that, but there's no AI project at all. That's how they get them.
Yeah, those are gonna be popping up more and more, I think. But yeah, there are a couple other blockchains out there that do have the same idea as us in terms of, we're gonna make a quantum secure blockchain. And QRL is one that's out there that's kind of along with us, one of the pioneers in the space in terms of just thinking ahead that far and building a quantum secure blockchain. But yeah, I mean, I think Cellframe offers way more utility than them, honestly, in terms of, what I mentioned about the high performance aspect. And we're very much geared towards making it easy for people to develop apps. So we have a software development kit where you can easily jump on and create like a decentralized app. And the thing is that we also have like a pretty cool innovation for apps themselves, where we have a smart contactless app. So, like as I mentioned, decentralization is a big part of Cellframe's vision. And actually, decentralized apps today aren't really all that decentralized because they are governed by a single smart contract that everything runs through there. It contains all the money. The keys are held by one person or a group of multi-sig holders. That group can be hacked. We've seen it. That's not really decentralization. So what we have is a way to build truly decentralized apps where it's actually the transactions are peer-to-peer. So we have a VPN that's I've been running for years. It's a really good app. You should all download it. Kel VPN runs on Cellframe. And it's a decentralized VPN. It's quantum secure, of course. And it uses this thing that I mentioned about peer-to-peer transactions. They're called conditional transactions. And yeah, so that we make it easy to build apps. We have a layer 0 structure. So if you're a company and say you want to build a blockchain, we can provide you the tools to build any kind of blockchain you want. You can have your own layer 1, but it'll be running on Cellframe architecture. You'll have quantum security built in, and you can do whatever kind of blockchain you want with whatever consensus and have full control. So as a layer 0 structure. So I think we're one of the most, even outside of the quantum issue, we're one of the most advanced blockchain platforms for builders to come build on. I think we offer a lot, and to be able to do that while also just automatically being quantum secure and not even having to worry about that, I think is a great pitch to builders and to companies out there.
And now that you mentioned some of the user base or potential users or clients that you have, is Cellframe mainly designed for large enterprises, or is it also something that regular users will also benefit from in using this kind of network?
Both. Yeah, I think that's a good question. And yeah, like I said, the with the layer zero structure, companies can easily jump in. Companies tend to want control. Um, that's one thing that sort of Ethereum Ethereum's been out there pitching their L2s to companies. They're saying, "Oh, come build an L2. You can have full control. It'll be fast, and you'll be on Ethereum." But they don't mention the quantum threat that's coming. It's going to be very difficult to migrate those L2s. Um, just to go off on back on a quantum tangent, in order to migrate from classical to the post-quantum upgrade, right? Ethereum and Bitcoin are both promising post-quantum upgrades. You might see somewhere someone saying, "Oh, it's going to take months to upgrade Bitcoin or Ethereum to post-quantum." But that figure of months, that's just the transactions. There's going to be, because you have to move every wallet across to a new address. So there'll be such a backlog of transactions that just the transactions alone will take 6 months, to migrate. And that's not even talking about how hard it is to build a consensus to do that, how hard it is to migrate all the smart contracts. You're going to have to unstake, unlock everything you have locked up, move it to a new wallet, and rebuild the entire ecosystem in the post-quantum space. So that's how much of a difficulty it is. If you are a company and you build your blockchain on an L2, suddenly you're going to have buyer's remorse because you have to go through this incredibly painful migration project, right? So that's just a little tangent back. But yeah, so back to your question, yeah, we think it's great for corporations, and then for everyday users. Also, as I mentioned with the apps, I think our vision is really to allow us to build post quantum Web3 decentralized services, and that's part of the reason why we have the C code. Like, for example, if you want to build a decentralized YouTube, which is something that we're looking at. You want to be able to feed peer-to-peer video at a high rate of speed. Decentralized networks can be great for that, but you need a high performance. You need to be able to tie it into the machine. You need to be able to control the hardware on the machine to be able to run different types of nodes in this distributed network. So as far as the user experience of the average user, what we envision is a real simple thing. You open your phone, you start you start streaming video, but you're doing it in a decentralized, censorship-resistant, peer-to-peer environment. So that's, yeah, the answer is both,
Actually,
I
really
guess.
cool. It's the first time I've heard you can applying that in a streaming method. This kind of yeah, sorry, in that kind of technology. So yeah, that's news for me. I need to look up more on that thing.
Yeah, that's the thing. I mean, the people have long thought that, like, oh, such things can't really be on chain because it's too much data, too fast.
Yeah.
You need centralized servers for that, but that's not really true. When you have a good enough network, you have the right software. It can be done, and it can have a lot of benefits.
Yeah, people might be thinking, okay, my streaming is already working fine on YouTube or Twitch, but I'm sure you had those times where it can always be better. It could be faster, like less lag and stuff like that. Those are just, I'm sure streamers, if they know about something that would be better, they would switch to it. But it's more on, will people actually take the time to adapt to that kind of change? And that being said, since yeah, you've established that quantum is protection and technology would be the future, but in terms of people catching up, that hey, we're missing out a lot and still staying in the typical blockchain that or the network that we currently use. If you could give not a prediction, but maybe some sort of forecast where people would actually need to start switching out to quantum. Do you see it in the next year or so, earlier, or maybe longer?
Yeah, that's an interesting question. It's been developing a lot for sure. Right now, we've had discussions within the Bitcoin core community that have happened over the past few months, I would say, that just weren't happening a year ago. And so there's awareness in the developer community, and I think as time goes on, it's going to become more and more pressing of an issue for them because there's people that we're in touch with, kind of the community of people who are really saying, let's go, guys. Like, we need to start this now. We need to have a consensus. We need to build the new infrastructure, and then we need to actually do the migration. Like, hey, and Vitalik's like said that he thinks in 10 years, maybe we have 10 years or something. Okay, if we have 10 years, that's fine. But if we have 3 years, then we're already late on that. So, yeah, as far as average people, I think it's a good question. I think it's going to be, people are becoming aware of it on their own. Like if someone looks into it, say they're like, oh crap, this is real. I just read like a few articles and like, why isn't anybody talking about this? They start Googling it. They're like, okay, maybe they find Cellframe, maybe they find, QEVM is a solution that is being built on Cellframe right now by, a team led by a man named Ian Smith, who goes back really far in cryptography and like a really interesting builder and individual who's been in the field for a long time. And there's people who are like really aware, of the quantum threat and are trying to do something about it, especially trying to save Bitcoin, because a lot of these guys are OG Bitcoiners. So I think what will happen is that we'll open up like a window for people who are already aware to start quantum proofing themselves, So people maybe will start maybe with a trickle, and then, but then, right, either that'll gain awareness on its own, but if the first quantum hack happens, then it'll be crazy, right? Because there's predictions about what kind of fallout could happen if, say, a quantum computer hacked, a Satoshi wallet. There could be a huge impact on the price of Bitcoin. The price of Bitcoin is now deeply embedded in the world economy. So there could be a huge financial crash if like an unexpected quantum scenario happened, right? Say China builds a quantum computer in secret, gives it to North Korea, and they just steal start stealing Bitcoin left and right. Could be an incredibly chaotic situation. But yeah, as far as like what's going to happen more closer to now, I think people will start saying, okay, I want to quantum proof my stuff. I think El Salvador actually had recently started, because there's ways within Bitcoin where you can kind of make yourself safer. There's different types of addresses in Bitcoin. So El Salvador recently like sort of secured their Bitcoin by transferring it to upgrading. But then there's going to be people that are going to want to secure their Bitcoin and other things. And QEVM is going to allow people to sort of migrate some of the Ethereum contracts over into a post-quantum space. So you might have like a bridge, two-way bridge, right? Because you basically, you have a token, like if you have Shiba Inu, you're going to have to trade that essentially for the post-quantum version of Shiba Inu. It's almost, you can do a one-to-one swap, right? So, but there might be a two-way bridge at the beginning. Say you trade your Shiba for post-quantum Shiba, and then you're like, nah, this is bullshit. I want to trade it back. So that might be like kind of the early days where there'll be like a two-way bridge.
And I guess with what you've mentioned, prevention is better than cure. I mean, crypto wallets, companies, major centralized exchanges are getting hacked already, and that's without this kind of quantum technology. And if you guys have an opportunity to do more, you can't be too secure in this phase because there's always someone developing better technologies to unfortunately hack someone. And what you've mentioned, if there's a major hacking that involves quantum technology, hopefully it never happens, but it's inevitable. Hackers are getting smarter, unfortunately, and people, no matter how secure they are, it just takes one good hacker to unfortunately exploit whatever they have, and yeah, it's going to be a lot of losses for everyone. So it's always good to be one step ahead of the game, maybe more steps. So having quantum protection will definitely help you. And another thing I would like to talk about is the Cell token, and it plays a central role in your ecosystem. So beyond, I'm not sure if it involves getting used for transaction fees, but can you tell us more about the token itself?
Yeah, that's right. It does. It has transaction fees that go into it. So we have the layer 0 network, right? That's called the backbone network in our system, and that's the network that connects all the other layer 1s. And so Cell is the gas token for that. So that's what you need. That's what you need to stake. It's a proof of stake system. So if you're a holder of Cell, you can run a node and collect gas fees, just like Ethereum or something like that. And so you can collect that. You can delegate if you don't feel like running a node on your own. If you do feel like running a node on your own, but you don't want to do any work to set it up, you can also buy a hardware node from us on the Cellframe shop. So that's a kind of a cool part of Cellframe that I don't think we have time to get into too deep, but we're definitely interested in hardware and building kind of a distributed networks and supporting that with hardware also. So there's a project called NodeSys that's doing decentralized hardware production. So they're also building us these hardware nodes. So yeah, so if you have Cell, you can run a node, you can delegate and get fees, and you can vote. So it is a user-controlled protocol, and so all the decisions about tokenomics and everything like that are going through a voting system. So that also has the Cell token at its core. Yeah, that's it. And then yeah, also this Cellframe auctions. That's another important use case where when a company or a project wants to have a dedicated layer 1, a chain, they need to participate in the auction, and that also involves the Cell token. So those are all so it's just the core. That's the core token of the whole ecosystem at its base layer.
And also, we'd like to also add, since we're speaking about a Cell token, we're actually doing a giveaway for everyone who's interested. And I do encourage everyone to join in our giveaway. We're giving away $500 in Cell tokens to 10 lucky winners. So just go on to the page we have here at Coinomi. I'm sure Cellframe, you've also shared this giveaway, I believe.
Yep.
Yeah. So if you want to join,
we'll post it again.
Yeah,
we'll repost it on Cellframe Social too.
And we'll also repost it on our socials as well, because yeah, you can be one of the 10 lucky winners right here. So if you're listening to this, it's not too late. We're still having it live, and hopefully you're going to be one of those lucky winners. And I would also like to ask, since you've mentioned having Cell tokens as part of having some sort of decision maker, so I guess that's DAO or some sort. Do you have any examples on how the community actually did something to help in the development of Cellframe?
Oh yeah, I mean the community. We have the core development team, but it's also an open source protocol. We have some amazing people building stuff all over the world. One example, we have a guy named Mika out in Finland in the woods. He builds amazing tools for Python, adapting the software development kit for users and making sure all those tools are being developed and expanded. We have some cool projects, lots of stuff by users. Where we have delegating. We have a website built by users for tracking wallets, for delegating, helping people set up a masternode if they want help. We have a cool meme coin called Chipunk. So they're also building utility into their coin. So we've got a lot of stuff coming in from the community. And then of course we have the people that are holders and supporters that help us spread the message online, try and do deals with partners, do awesome posts and videos. And then people also have been voting. So we've got that mechanic in place already. So we had a vote on tokenomics this past year as well.
And unfortunately, we're kind of running short in time. As much as I want to ask like tons of other questions, because it's a totally new technology for me. And as you mentioned earlier, not a lot of people are catching up currently with quantum kind of computing. In the blockchain. So I guess in the the last part of the spaces. So if you have any announcements, you can also feel free to add that as well on top of this question. So looking ahead, maybe I would say 5 to 10 years, but that's way too far ahead, given that how fast development comes in this space. So let's say in 2 to 5 years, what is your vision for Cellframe's role in the blockchain industry and maybe everyday applications?
Yeah, I mean, interesting kind of announcement type stuff that's happening now. I mentioned that we produced a hardware node. And we have, so this is something I see in 2 and 5 years. We have an app called the Cellframe Wallet, which is more than a wallet. It's like a portal into different services. So it's envisioned as kind of a super app. And I think in 2 and 5 years, you'll be able to access a lot of cool stuff through your Cellframe Wallet in terms of peer-to-peer services, and you'll see a flowering of a Cellframe ecosystem, because not only are more people going to realize that they need to build post-quantum into whatever they're building, but people will also see what we've been building. Cellframe has been building for a long time, and it's really all about developers. And we really have a great development kit for these peer-to-peer apps. And I think in 2 and 5 years, you'll be able to vibe code an awesome peer-to-peer app. Maybe you have maybe you can even do small scale apps. Like if you have a school, you're like, all right, let's put out a token, run an app, and people will be building on Cellframe, and they won't have to worry about everyone else scrambling to beat the quantum threat. And they'll be using cool development tools on Cellframe to do amazing things, decentralized apps. We're seeing the promise of what the internet was supposed to be. Things, you kind of get what you want in life, but like 20 years later, maybe. That's how it happens. So like in the 90s, people thought we would have this amazing decentralized internet. Then everything got super centralized. But I think now is going to be the time, 5 years from now, people are going to see a real decentralization happening, and it's going to be accelerating.
It's bound to happen, whether you like it or not. Decentralization is the future. It's just a moment of when. It's not like something that you're gonna ponder upon if is it gonna happen or not. It will. It's just a matter of time. So so that's
Nice,
it for
yeah.
our spaces for from Cellframe. Sorry about my phone; it's not doing so well. And also some announcements. Sui is currently live on Android and soon on iOS, and we're currently offering 50% off fees in Simplex for on and off boarding. So, you guys at Cellframe, do you have anything else you would like to add? Any announcement that you probably missed earlier on, and any, I guess, any messages for your community and would be clients or future members of your community? I would say.
Yeah, I mean, if you're new to Cellframe, come join our socials. We have a very welcoming community. Download the Cellframe wallet, start playing around with it, get some tokens. You know, you'll be one of the first to hold a quantum secure token. And yeah, join in, get some hardware, get our software, jump in our communities. You know, we're already integrating with some exchanges with our native protocol. That's an interesting process. You know, like have a whole new quantum safe protocol that exchanges are adopting. So big things are coming up, and it's fun to hang out and learn about quantum computing on the way too. So come on in.
So if you guys have just heard of quantum, yeah, it is definitely developing and being adopted fast. And as we've talked about earlier and during this spaces, it is the future. So if you don't know about quantum, feel free to go jump onto Cellframe's socials, and I'm sure that they're going to be more than happy to answer more of your questions, or just read about on their website to know more. So thank you once again for being with us here at Coinomi Connect, and we'll hope to see you again in the next spaces. And that's it from us. And don't forget to leave a 5-star review if you're happy with us, and if not, feel free to ask us some questions, and we'll be we're going to be doing our best to make sure that you get the best kind of service at Coinomi. So, okay,
Perfect.
over
Thank you.
now. It's an amazing, it's been an amazing experience, and I'll be definitely learning more about quantum in general, and of course, Cellframe in general, and hopefully the listeners here will do as well. See you guys. Bye.